Assalamualaikum warahmatullahi wabarakatuh. So today we will do the MANOVA project. So this is all the lecturer involved in this project. So moving on to the team members. So my name is Muhammad Ibrahim. I'm the leader of this group. My team number is 198178. And also the other teammates Vignesh Wari, Jin Ling, Hani Sufia, and also Salman. This is all their matrix number. And also we are from group 6. So moving on to the abstract, I will explain a bit before the abstract. I will talk about the objective. We've got two objectives here, which is the first one is to identify the plastic ball with different diameter and initial temperature. Will affect the number of bounds of a plastic ball which drop from the different initial height in the certain humidity of air. So for the second one, we'll measure the time taken for the plastic ball with different size and initial temperature drop from the different initial height. Moving on to the abstract, the time taken for the plastic ball drop was optimized using the MANOVA, and these three independent variables, which is initial temperature, diameters of the ball, and also initial height. So this is three constant variables: degree of incline, 90-degree, humidity, and density of air. So this observation will be optimized. We get a result with different method, and the result will be compared to identify.
For the hypothesis of the experiment, all the independent variables has effect towards the dependent variable. The time taken for ball to stop bouncing and the number of bounce increases when the diameter of ball decreases. Besides, the time taken for ball to stop bouncing and number of bounce increases when the height of the ball drop increases. The time taken for ball to stop bouncing and the number of bounce increases when the temperature increases. Furthermore, the diameter of the ball are the factor that give the most effect towards the dependent variables.
I'm going to talk about the protocol of this experiment. First of all, the materials we use in this experiment: plastic ball, measuring tape, stopwatch, marker pen, tile floor, strings, and stop. First experiment talk about the time taken for plastic ball with stop bouncing with different diameter and different initial height. Second experiment is talk about the number of bouncing for plastic ball with different diameter and different initial height. First experiment is talk about we have to use three plastic ball with different diameter and initial temperature to put in the refrigerator to reduce the temperature. We have to start the stopwatch when the plastic ball is dropped from the height of 50 centimeter to the tile floor, and we have to stop the stopwatch immediately once the plastic ball is stopped bouncing. And we have to repeat it 4 times to obtain a total of 4 records and record a data table. We have to repeat all of these steps. We have to repeat step for 4 to 9. The plastic ball with different initial temperature. After that, we have to create the average for the all balls. So experiment 2, it will be the same, but we have to know the bouncing of each ball. The initial position of the plastic ball with 5.5 diameter is from the tile marked with a marker pen. It will be the same, but we have to calculate the bouncing ball.
Experiment 1, the result I will talk about. So in experiment, we're focusing more on the time taken of the ball achieved. So the temperature is 225 and 36, and the height of the drop, which is 50, 100, and 150. So the diameter is 5.5, 6.5, and 7. So we also get calculate the average of the time taken, and so we do the 4 repetition. And the second one is experiment 2, is the same as experiment 1, but the difference is just the number of bounds here. We observe number of bounds instead of time taken. So with the same 4 repetition, we calculate the average of the number of bounds.
Analysis. The purpose of MANOVA. MANOVA is utilized to test hypotheses regarding the effect of one or more independent variables on 2 or more dependent variables. For our experiment, we have 3 independent variables and 2 dependent variables. MANOVA procedure allows us to test our hypothesis for both dependent variables at the same time. We solve MANOVA using IBM SPSS software and also MATLAB. Here shows the descriptive statistic where we can see the minimum value, maximum value, sum, mean, standard deviation, and variance for all the variables. Table 4 describes the box test of equality of covariance matrices, where it used to test null hypothesis that the observed covariance matrices of independent variables are equal across the groups. The null hypothesis for our experiment is covariance between time taken for the ball to stop bouncing and number of bounce will be same for all the height ball dropped, diameter of the ball, and temperature of the ball. Since our significance is 0.824, which is more than 0.05, so we cannot reject our null hypothesis and we can perform the MANOVA. For our analysis, the confidence interval is 95%, so we set our significance level at 0.05. Here shows the multivariate test. SPS gives us 4 different forms to test our F value for MANOVA. All of them are used to test whether the vector of the means of the groups are from the same sapling distribution or not. For our experiment, we choose Pillai trace since it's the most preferred approach for the F value, as this is the least sensitive to the violation of the assumption of the covariance of matrices. For the first independent variables, which is the diameter, the value is 0.97 and the F value is 38.116. This is a significant at the 5% level, as the p-value is 0.00. So we can reject our null hypothesis, which is the diameter for the diameter will be same for all the dependent variables. Overall, we can reject the null hypothesis, which is time taken ball to stop and number of bounces will be same for all the height ball drop, diameter of ball and also the temperature of the ball.
Now I will continue on the analysis part. Okay, this figure are known as the estimated marginal means figure, where it is generated from the SPSS software. So estimated marginal means is useful to determine the trend of our factors towards the dependent variable. So as we can see from the figure, when the diameter of ball decrease, the small ball, the marginal means increase. Mean that the time taken increase. Okay, so when the height of ball increase, which is at the green line at the 150 centimeter, the marginal means increase. The marginal means for the time taken increase, and also at the temperature. For the temperature, when the temperature of ball increase, which is at the hot sun temperature, the marginal means for the time taken decrease because it recorded the lowest marginal means here. Okay, so for the number of bounces, it also shows similar trend, just like in the time taken, where when the diameter of ball decrease, which is the small ball, the marginal means for the number of bounces increase, and for when the height of ball drop increase, the number of bounces, the marginal means for the number of bounces increase, which is the green line, and when the temperature of ball increase, the marginal means for the number of bounces also increase. So as we can see here, all the analysis made, so we can see that we can sort. So we can say that the hypotheses made are aligned with the analysis. Okay, the next one. Okay, so for the linear regression, this linear regression model is done using the MATLAB software. So we are using the curve fittings to find the unknown of A. Curve fitting is done using this equation to find the unknown of A. Why we want to find the unknown of A? Because a factor is said to be the best impactful when it has the higher value of A. So as we can see for the time taken experiment, the higher value of A is 0.19, which is for the factor 1, which is the diameter of ball, and for the number of bounces, also the diameter of ball. So what I can say that is the diameter of ball is the best impactful factor towards both the dependent variable. Thank you.
Okay, now we proceed to the conclusion of the experiment. Since the Pillai's trace shows significant results, it can be said that the impact of diameter of the ball, which is the first independent variable, on the super-dependent variables such as the time taken and number of bounds is significant. For the second and third independent value, also the Pillai's trace is significant. Hence, the height of the ball drop and temperature of the ball. The test between ball drop effects also shows significant results. So the impact of first independent variable, which is the diameter of the ball, on the first dependent variable, which is the time taken, is significant. Similarly, the impact of diameter of the ball on the second dependent variable, which is the number of bounce, is also significant. The impact of the second and third independent variables, which are the height of the ball drop and temperature of the ball, on the first dependent variable, which is the time taken, is significant. The diameter of the ball plays the most significant role, and the temperature of the ball plays the least significant role on both. All the three independent variables have effects on the dependent variables. However, the diameter of the ball have most significant effect towards the number of bounce and time taken to stop bounce. Second impactful independent variable is the height of the ball and least on effect of temperature. We reject the null hypothesis that covariance between time taken for the ball to stop bouncing and the number of bounce will be the same.